Good afternoon, everyone. This is Candice speaking here. I'm technical support engineer from SuperMap Asian Oceania Center, and today we'll be responsible for presenting the training for day 2. So now let's get started for the first material.
Sorry, how to call you?
Sorry?
Your name?
Candice.
Mrs. Candice.
Yes.
Okay. Сегодня она будет у нас представлять вторую презентацию. Mrs. Candice. Продолжим вчерашнюю работу.
Okay, so today the first topic is the Geo-Referencing and Digitization. And this is the outline for today. We will learn about how to register map on SuperMap, assign coordinate system, vectorized region, define height, and extrude 3D model.
Сегодня мы научимся, как регистрировать, как надо указать координатную систему, как надо указать векторные данные, как надо определить 3D-модель карты.
Before we go to the technical part, I have some slides to let you know about the concept. The first one, I want to let you know what is the definition of data registration itself. So data registration is the process of correcting and transforming the spatial position of the source data according to a certain algorithm and a set of control points. And we will need 3 data here to process. The first one is the source data, and second one is the control points. And we will get a result that already have a coordinate based on the control points we assign to the source data.
Сегодня мы научимся, как регистрировать данные. Дадим немножко определения на данных. Это процесс корректировки или трансформации данных в соответствии с определенным алгоритмом. Не бывает у нас данные, источник данных, результирующие данные и контрольные точки.
In SuperMap, we have 3 different ways to do registration. The first one is registration by inputting coordinates of control points. Second one is registration by picking control points from the reference layer. And the third one is batch fast registration. And for today, we will learn about the second one. So we will do registration by picking control points from the reference layer.
Для того, чтобы регистрировать данные, мы можем использовать 3 способа, и сегодня мы будем рассматривать с вами второй способ. Это регистрация данных с использованием контрольных точек внутри слоя.
And this is a workflow for the first 2 methods, which we will learn today. So we will create a new registration, select the reference data set. This can be skipped if you don't have. And the third one is select the algorithm, pick or enter control points, calculate error, execute registration, and finally we will obtain a data that have a coordinate system.
Для того, чтобы установить координатную систему, мы сначала должны регистрироваться, потом мы должны указать данные, источник данных, потом мы должны использовать алгоритм регистрации, потом мы должны ввести контрольные точки, вычислить ошибки и выполнить эту регистрацию.
All right, now we will go to the SuperMap ID stop, and I will let you know how to do so. So we will use the same software as yesterday. This is SuperMap ID stop, and I already shared with you the data. We will be using the first data registration and extrude 3D model. We will extract this zip file. To data, we will use the New Haven map. The second one is the reference points. This New Haven map is a picture like this, and it has no coordinate system. It has no coordinates. So we will assign coordinates and also coordinate system to this picture based on control points that we already created before.
Сейчас я буду использовать вот этот сжатый файл. Надо его заархивировать, и внутри у нас находится рисунок. Вот этот рисунок сейчас не имеет координатную точку, координатную систему. То, что здесь создано, это было создано раньше. Мы на эту рисунок будем создавать координатную систему.
Now we go back to the SuperMap ID stop. The first thing we need to do is create a data source. You can right click on the data source and click on new file data source.
Сейчас в рабочей области вы должны создать новую файл данных. Для этого нажмите правую кнопку мыши Data Source и выберите команду «Создать новый источник данных».
Okay, after we click new data source, you can go to directory file. Create new folder and put the data source name here.
После нажатия у нас откроется окно, и там вы должны в окне создать новую папку, дайте имя process и дайте имя вашему файлу.
All right, then we click save and new data source will appear here. Next process, we will add new data set to the data source. You can right click and click on new data set. Right click and import dataset. Then you can click add file and select the data. Data will be import is New Haven GPG file and the shape file of reference points. Then you can click open until it appear here. So these two data will be imported, and you can click wait until the project is finished.
Нажимаем правую кнопку мыши в новой созданном файле и выберем команду импорт данных. Далее выберем вот рисунок в папке и нажимаем импорт. Вот этот рисунок будет импортироваться на рабочую область.
Okay, now the data is successfully imported. Let's take a look how the data looks like. By double click on data.
Два раза нажмите на рисунок, и у нас вот эта карта откроется.
Sorry, I did wrong share screen. Let me share it again. you can double click on your heaven or right click and select add to new map. And this is how the data looks like. So this is a map, a picture map. And this is how the reference points look like. So it has 4 points here that representing each edge of the map. So if you take a look like this.
Когда мы добавим вот карту, у нас появятся 4 точки, которые указывают углы этого рисунка.
As you can see, this point is representing this edge, this point representing this edge, and so on. Okay, next process is we will do the registration. We need to close this all. And you can go to data, start, and we have registration here. You can select the new registration.
Перейдите во вкладку «Старт», и там есть у нас команда «Registration», регистрация, и нажмите на «New Registration».
New registration, and the first thing we need to import is select the registration data. This registration data, it should be the picture, the new heaven map. So we will be deleting this one and select the new heaven picture, the image one, click OK.
Чтобы добавить этот рисунок, то, что там имеется, мы должны сначала удалить, потом нажимаем на первую кнопочку, чтобы добавить этот рисунок.
Then you can click Next. And the step 2 is select the reference data. It should be the points. We can click Add and choose reference points. Click OK. Then we can click Finish. The window as follow will be appeared. The registration layer and the reference layer.
У нас окно делится на 2 части. В одной части мы увидим слой регистрации, а в другой части мы увидим слой ссылки.
Okay, the next step is add control points. As you can see, the cursor is changed into plus symbol like this. And we need to go to each edge of area that's represented by this point. You can go to this area, digitize, and go to the reference layer and digitize. So now we already picked one point that representing the same location, both on the picture and on the reference layer.
Мы должны сейчас указать контрольные точки. Когда мы позиционируемся курсором мыши, у нас курсор имеет другой вид, и надо выбрать вот эту точку, увеличивая вот этот рисунок. Выберем первую точку.
Sorry, Candice, we can't hear you.
Sorry, I'm still muting myself.
Oh, okay.
Okay, last part it is digitization, right? Please make sure that we digitize the 4 points sequentially from the registration layer and then reference layer. So after you digitize the first points here, then you go to the reference point, go back again to the registration and go to the reference layer until all the point already digitized on the registration layer. And then we can see the coordinates here, source points X and source points Y. It should be representing the reference layer, and target points X and target point Y. It should be representing the registration layer. Next step is calculate the residual, this one, this 2 column. To do so, you can go to calculate error, this one. Click on the calculate error, and it will automatically calculate the residual X and Y. And you can also get the RMSE here for each location. There will be translation or not? Or I can go to the next part.
Yeah, source point, источник, точка источника, x точка источника y, оно указывает в слое ссылки вот эти точки. А target point x, target point y, он указывает данные вот из этой карты контрольной точки. Далее следующее, вот остаток, разность, да, он показывает разность между этими двумя контрольными точками.
Okay, next part. After we calculate error, I advise you to get residual until less than 1. This residual unit is in pixel, and better to have residual less than 1 pixel. And so if you notice one point have big residual, for example, this one is the one that have high RMSE. You can delete this. Right click on the row, click delete, and digitize again for the first point.
После того, как мы вычислили вот разницу, мы видим здесь, мы получили значение больше, чем 1 пиксель. Поэтому вот первую строку мы должны выделить, удалить, и заново мы должны указать контрольные точки.
Okay. When you finish, you can right click and calculate error again. Get the new RMSE. And if you are already satisfied with the number, you can click registration. You can select the resample result. We have some method here, nearest, linear, or cubic. We will be using the bilinear one, and click OK.
Мы еще раз должны нажать на Calculate Error, потом мы должны регистрировать это.
And then wait until the process is finished.
Подождем, пока этот процесс не завершится.
period, the length of period to process this is really depends on your computer specification. And now we already have the result here. It characterized with this text adjust. So if your result is the original file name _ adjust, it means that this one is the result. And you can take a look at the result. You can right click and add to new map. If a dialog appear like this, which asks you whether to build a pyramids or not, you can just click yes, because it will improve the process of displaying your data.
После того у нас результирующие данные, да, вот файл с именем New Haven Just. Нажимаем правую кнопку мыши и выберем команду «Добавить» на карту, и программа запрашивает у нас применить эти изменения.
Is we will digitize some building. If you take a look here, some area on the picture, the map picture is a building, so we are going to digitize the building. And fill the height information.
Сейчас мы построим высоту.
Now this is the result. It's totally different with the one that we have, right? Position, the position is totally different, but this one, it should be the correct one that representing real world is on our reference points. And if you take a look, you can right click and go to the properties. Here we have coordinates, and it shows that this map already have coordinate system. And this one, the original one, it doesn't have coordinate system.
После применения вот в предыдущем рисунке мы не можем увидеть координатную систему, а в новой мы можем увидеть координатную систему.
Next, we will digitize some building here. Let's assume that this rectangle is one building, so we will digitize. You can right click on the reference, Geo-Reference, GMO, UDBX or data source. Right click and click on new dataset. Okay, now we will create one polygon. You can change the type into region and change the dataset name, for example, building. And don't forget to change this coordinate system as well. You can change as I will be using the WGS 1984 this time, but should you want to have the same coordinate system as New Haven, we can copy coordinate system from New Haven later.
Сейчас переходим на нашу базу данных Geo-Referencing Demo. Потом нажимаем правую кнопку мыши и выберем вот, координатную систему, будем применить. Можно увидеть, посмотреть там здание.
Right. You can see here that you have an AD 1927 UTM zone 18 north, but our building is on WGS 1984. So if you want to have the same coordinate system like this one, you can click on projection transformation and copy the coordinate system from the reference points or from the New Haven. It's just the same. Click OK. And now click convert. And this new building _1 is have the same coordinate name as you have it.
Если вы хотите отменить координатную систему, которую мы только что применили, мы можем вот предыдущую выбрать и здесь команду выбрать отменить и отвергать вот эту команду. И вы можете увидеть здесь предыдущую координатную систему.
Okay. How to digitize is very easy. You can drag this to the main map like this. And until this dataset appear on the layer manager, click on pen editing tools. You just need to double click on that until the color change into blue and go to the object operations and click on region.
Чтобы редактировать вот это, мы должны перейти в свой Layer Manager, и там у нас есть вот третья кнопочка, позволяет редактировать. И цвет вот этого слоя изменяется на синий. И потом можно перейти в Drawings и выбрать команду Region.
Okay. And digitize, wait until the cursor changes into plus shape like this, and you can start to digitize. And when you finish, you can right click. If you want to continue, you can digitize again. When you finish, you can right click and go and so on and so forth. Okay, it's done. Now we will assign some height to this building. You can right click on the building _1.
Сейчас мы можем
Rows attributable.
применить высоту для этих зданий.
Okay, now we will add new column to our data. You can go to attribute table, click plus.
Сейчас мы добавим новый столбец. Перейдите в окно свойств и вот класса знак плюс нажмите.
Okay, and then change the type. We can change this name into height and change the type into double and click apply. And now new column appear here. And we can define some number.
Имя этой колонки называется High, и тип данных укажите Double. Здесь вы можете увидеть, что это столбец добавлено, и вы можете указать значение высоты.
All right. Now this 4 building have height. We go back to the map window and click save. We will save the map. For example, the map is New Haven. Click OK, and it will appear here. Now,
Теперь вот эти здания у нас имеют высоту.
Okay, the next step is we are going to open our New Haven map and our building data. You can select this too. Just use Control to select, or you can add one by one. For example, I will show you how to add one by one. You can right click on the map and add the new spherical scene. And now our New Haven data, you can resume to layer. It's opened on a scene. And do the same for building 1. You can right click and add to current scene. Okay, next we are going to extrude the height. You can go to the style settings, change the altitude mode as absolute, and the altitude is height. And also the lift height is height. On this one is you can just, okay, sorry, the altitude is 0 and the lift height is based on the height column. So it will be appeared like this. And we can change the color, change the foreground. Sorry, I mean, we can change the texture. You can click on texture setting and select the texture file. This one is for the site. So we will select the site file, click open. And select on the top texture. And go to the top one. In my computer, it should be changed the texture, but if you see black only on your side, it's probably because of the limitation of the conference. But if you try by your own, it should be changed based on this texture file.
Для этих зданий можно изменить внешний вид. Для этого мы должны перейти в Style Settings, и там мы должны выбрать, что мы вот эту высоту выберем. И внешний вид вот это здание можно изменить. Со сторон, да, рисунок мы можем выбрать, и сверху, как оно будет выглядеть, рисунок можно выбрать. У нее на компьютере оно медленно работает, поэтому вот эти изменения не видно. Но если по одному вы сделаете на ваших компьютерах, тогда вид вот этой здания будет изменяться.
Okay, so I think this is the first topic I already delivered to you. And we now go to the second part, which is spatial analysis. And we will have 10 minutes breaks and we will go back at 10 minutes again. Please stand by and see you. Okay, the next part is we will be learning spatial analysis. Okay, so previously we already learned about geo-referencing and digitizing. And next, we will try to learn about how to do buffer analysis, spatial query, and overlay analysis. Sorry, there are typo here. First, we will learn how to create buffer. So buffer itself, we are trying to make a larger shape from the original one based on specific radius. We can create buffer for point, line, or region, and the left and right buffer radius can be different for lines. We can define it differently. Union buffer can dissolve the left and the right buffer space, and the buffer end type for lines can be round or flat. And today we will be creating a buffer for line. This is parameter we will need to fill for a create buffer. We need to fill the radius information, whether it's round or flat, or it will have different shape for the left or right, and so on. We also can create multi-buffer zone. So should you, sorry, there will be a translation, or may I continue? Okay, I will continue. So for creating multi-buffer, we can define more than one radius. For example, this time we create buffer for 55 meters, 65 meters, 80, and 90. we can create multi-buffer zone for points, line, or region datasets. For example, we can utilize this for a railway analysis to analyze different levels of noise affection to the residential areas nearby. And this is some options for us to do the overlay analysis. We can have a clip. We have overlay mode clip, erase, intersect, union, identify, XOR, and update. Okay, now we will go to the SuperMap ID stop. We will save the scene. You can right click, save scene, and put the name, and click save. Okay, now we can close this one.
Mr. Gans, your window is not visible. We see your presentation.
Sorry. Sorry, I still present the ID stop, but what I've done before is this is the latest layer, right? I save the layer, I save the scene. You just need to right click, save scene, and you save scene, and then you will need to fill the name, and then you can close it, and it will appear here as a new scene file. Okay, next step is we will import our data. You can right click on data source and click on open file data source. And this is our data, special analysis and query. Sorry, I forget to unzip the data. And right click and extract here. Okay, now we go back, right click, open file data source, and go to special analysis and query and click on modeling and analyze. Click open. This is the file we'll be using. Select these two data sets, right click, and add to new map. Okay. Next part. We are going to query a data query using SQL. We are going to select this layer. This layer, it should have name Xingyi root, this one. But we will use SQL for search that layer. You can go to data, special analysis, SQL query, this one. A new window will appear as follow. First thing you need to make sure is that data you select here is the road line. And this is the field of the road line. Next, we go to the right side. We need to select. We can clear this one. We need to select all. Select all field type. And the condition will be written here, where the road name space is equal to, you can click on get unique value and select the Xingye Road. Double click on Xingye Road. And this is the result. The road name is Xingye Road. And you can also add other operator by click on here and probably sort by or others based on your requirements. And for the result, we will highlight on map and save the result as Xingye Road. Then you can click on the query button. And this is the result.
Перевести или всем понятно?
Okay, after we obtain the result, the next step is we will do buffer analysis. To do so, you can go to spatial analysis, vector analysis. We have buffer zone here. Click, and there are some options: buffer zone, multi-buffer zone, and 3D buffer. We will select this one, buffer zone. Click on buffer zone. And next step is define some parameters. The first one, we need to make sure that data we are going to analyze is the Xingye Road. We can select this one, Xingye Road. You can uncheck here, select the Xingye Road, and go to the buffer type. I will be select round. You can also select flat probably. And in the result setting, I will just let it default. In the buffer radius, I will change the left and right radius as 20. And in the result data, I will change the data name as Xingye Road Buffer 20, like this one. And then we can click OK when you already defined all important parameters.
So, sorry, Ms. Scans, our participants asked you, can you send us the source files?
The data, the resources data, right? I already shared the data with Olga. I think after our today session, Olga will give you data and the PPT as well.
Окей.
Окей.
Она сказала, по окончании пары она отправит нам и презентации, вот данные.
All right. Next step, we have the data result already here. We can change the order layer by manually drag like this. And we are going to do intersect analysis. As you can see here, this is the Xingye Road, right? Road that we, the query result, or we can also import it here. This one. This one is the Xingye Road, and we already do buffer analysis for 20 meters. And based on our visual interpretation, it shows that it intersects some building. You can see this building overlap with this result, right? With this buffer result. So we are going to analyze which building that intersected or overlapped with our buffer zone. And to do so, you can go to spatial analysis, vector analysis again, and click on overlay analysis. In the overlay analysis, there are some options: clip, merge, erase, intersect, identify, XOR, and update. We will select the source data is our Xingye Road Buffer 20, and the overlay dataset is the model region, the building, and we will save the result as building intersect. Okay, now we can click OK, and with the result, drag to the map, and this is the result. This building is have intersection with our buffer road. Okay, I think this is the second material about overlay analysis. Next, we will be learning about query, but actually this part already covered with the previous one. When we click on SQL query, this one is how to have a query in SuperMap. Okay, and there is another option for us to do query. We have two different methods for query analysis. We have SQL query and we have spatial query, and it's have different objective. If we select the SQL query, we need to define the condition here. But if we choose spatial query, it will be like this. We will turn off these three layers, building, the Shingi road, and the road line, and we will select this buffer result. Okay, if it already highlighted like this one, it means already successfully selected. You can go to spatial query, and our data that we are going to analyze is two layers here, the buffer result and also the building. And the building is the model region. And we can select the model region here. Type if region, layer name if the layer name is model region, and the spatial query condition is intersect. You can save the result field. Intersect spatial query. We can click query here. Or we can close this, and this is the result. So now we already know which building that affected by road widening. Okay, if you take a look here in the attribute table, you can take a look the building height, the building name, and so on.
Can I translate it?
Yeah, sure.
Okay. Вот моделирование и анализирование мы должны сначала вот два файла сюда мы импортировали, а потом среди вот этих зданий, чтобы построить дорогу, да, допустим, вот новый слой мы добавили сюда и указали, что ширина у этой дороги будет 20 метров, примерную вот дорогу указали, и где у нас вот пересекается здание с дорогой, это мы можем увидеть, оказывается, здесь. И там мы можем также анализировать, какие здания именно вот пересекаются с дорогой, с другим цветом у нас выделено. И когда мы построим вот этот модель, у нас в SQL еще одна таблица будет готова, где будут указываться вот данные здания, как оно пересекается, высота, ширина, все данные, оказывается, там указывается, мы можем их редактировать. Thank you.
Okay, we go to the next step. So after query analysis, it's schematic map making and layouting. Okay, for this section, I will be using the same data. I will be using this data. We can save this map. Save map as spatial analysis map. We can save, close, and next we are going to add the same data again. But before that, I want to let you know that we are going to make a thematic map of the road and also the building intersect. We will be selecting this model region, Xingyi road line, Xingyi road over 20, and intersect spatial. You can right click and add to new map. Okay, we will turn this layer off and start with handle the model region. So in SuperMap, we can create a thematic map by right click on the model building and select create thematic map. But before that, let's take a look in advance how the attribute field. You can right click on the model region, browse attribute table, and it have different number of floors, right? There are buildings that have floors 3, 4, 7, 1, and others. And we will be creating a thematic map based on this floors information. To do so, we can right click on our model region, create thematic map. There are some options whether we will create thematic map based on unique values, range map, labels, graph, graduated symbols, dot density map, or custom map. And we will use the unique values and choose default. Click OK.
Could you wait a while? После моделирования вот этой дороги мы можем тематическую карту сделать. Сейчас она показывает, как уникальную тематическую карту сделать. Thank you.
Okay. And now, thematic map window will appear in the right side, and we will use the expression is floors, this one, and we will have different colors based on the number of floors. If the total story or floors on that building is 1, it will have this color. If it has 2, it will have this color, and so on and so forth. And I will change the color scheme. You can just expand this one and select some colors. For example, this one. And I don't have it has outlined. You can select this all. Control plus A. Click on this one, styles, and change the line. Click next. Change the symbol of line into null. Click OK. Click OK. And now it has no outline. You can turn off this one, this layer. Now it has no outline. Or we can change to another color, for example, this one. Or based on your requirements. Okay. Next step is we can give style for the road. We can click on road line and change the style. You can right click on road line, go to player style. Should you didn't want to change or create a thematic map based on specific field, you can just go to layer style. But if you want to create a specific thematic map for specific attribute table or field, you can select the create thematic map instead. But for this one, I want to have the same style for the whole road line, so I will select the layer style instead. You can click on layer style, and layer style dialog will appear on the right side. You can change. For example, I will be using this one. Or if you want to just change the line color, the width, you can define here. And then I will change the buffer result. This one, I will change the order after moderation. I will set it has no, I will set the color as maybe dark gray, and this too dark, maybe this one, and has no outline, and it will be shown like this. And next, I will change the style for the affected building. This one, I will set it has no foreground, but it has outline color red, like this one. Or probably blue, but it's too hard to detect. Maybe now it's good. So when you see this map is show that the building that have outline is affected by the road widening. Now we can save this map. Save map. Thematic map road widening. Click OK. And now we have this map. The next step, we are going to give a layout for our thematic map. We can close this map and you can go to layouts. All right, you can right click new layout. You can select the blank template instead. Now a blank template will appear on your map window. It has no map here, and question emerge how to add a new map. You can go to object operations. Here we have maps. You can select the shape. I will be using rectangle, but before that I want to change the layout to be I want to change the orientation to be horizontal. All right, next go back to object operations, select the maps, choose the rectangle and draw a rectangle. The map we are going to lay out is the thematic map. Click OK, and the map will appear. This one, but before that, I want to make outline. I can create a region, rectangle, and order in the bottom. Okay, next, we can change the color. The line color is soft gray. This one as well. Or just let default for now. We can change the center. You can go to layout, focus map. If you zoom out and zooming out, the result will be focused on the map. Click this again. And now we will add a text. And give the title. Sorry. If you want to change, you can just right click and
while you adding your title, I will translate it. Okay.
all right.
Она только что создала тематическую карту. В тематической карте некоторые здания можно раскрасить на разные цвета. Можно изменить их параметры. В отдельные слои мы можем модель построить выделенных объектов. И после того, как готова у нас вот эта тематическая карта, можно добавить сюда название этой карты. То есть она то, что показала вовремя, вот не успела сразу перевести, так быстро показывает. Может, в инструкции написано.
We will add some map objects. You can select the map, click on object operations, click on north arrow. You can draw in north arrow this one. If you want to change, you can just click on this one. Go to properties, and there are some options for the north arrow. And if every time you want to add object based on your map, you need to click on your map first, and this will be activated. If you don't, this will not be activated anymore, so you cannot click on that menu. I will click on this map again and add others object. For example, add new scale.
Как только готова будет у вас вот эта карта, можно, оказывается, добавить разные объекты. Да, можно масштабы указать, можно здесь сетку указать, можно легенду добавить и можно указать направление.
Click this again to give a grid. You can also click here and go to map grids on the right side. Click plus and then select the grid option. For example, I will give a measure grid, this one.
Можно, оказывается, добавить сетку, и у этой сетки можно указать размерность.
Sorry, since the data is on critical, on longitude latitude, I will be selecting this one instead.
У этой сетки можно, оказывается, размерность изменить, количество колонок или строк можно изменить.
All right, and others is the legend. Can draw legend here. And this is the result. If you want to change the order or others, you can right click and ungroup that one. you can do some modification. For example, delete this one, delete the road line and the building. So
Если
now
вы хотите изменить расположение вот этих объектов, можно разгруппировать и можно потом изменить.
and do some adjustments. And we can change this title as maybe number of okay. So this is our result. The result might not really good because layouting is need time to do some adjustment to make good color and others. So you can just explore the layouting process in SuperMap based on what I have delivered to you. So now we will save the layout.
У этого слоя вы можете изменить цвет, вы можете изменить расположение объектов, то есть выравнивать на разные стороны.
Okay, now we will export the result as picture. You can go to layouts, export and print, and select as picture, and click OK.
Теперь этот слой мы хотим сохранить в виде рисунка, выбрав команду Export слоя, Export to Picture.
I don't know where I set this with. Should be here, and this is the result. Okay, now we go to the next topic, which is network analysis.
Теперь мы переходим на следующую тему анализирование сети.
So in SuperMap, we have two types of network, 2D network and 3D network. And it has two different network model, the transportation network that has no directions and facility network model that has directions.
В SuperMap у нас есть два вида моделей, 2D модели и 3D модели. 2D там направление не указывается, а в 3D можно указать направление.
What is network? So network is a model which is composed of a group of interrelated arcs, nodes, and their attributes. The basic concepts involved in network are nodes, this one, arcs, this one, the line, network resistance, center points, obstacle edges, obstacle points, and the turntable.
В сети указываются узлы, арки, центральные точки, углы. Resistance.
All right. And the first thing before we do network analysis, we need to create the network model. How to create? We need to prepare data set to build the network data. It should be the points. It's optional, but the mandatory one is the line data set, which representing the line, the road, and prepare the field information of network dataset to ensure that the line data used to build the network contains a field that denotes the network resistance. For example, information about which line is one way only, which lines is can be to have more than one way, and others. You can add new column that define the information of each line.
Чтобы создать модель, мы должны сначала подготовить данные, вот совокупность данных. Мы можем указывать там точки данных, и мы можем указывать линии данных. Мы будем использовать здесь road node, узлы дорожек.
Okay, now we go to our iDesktop again. We'll close this. Open data source. Okay, this is a workspace, so we will be closing this one. We will save the workspace. Click save. You can close this and open existing workspace from the network analysis folder. This one, the junction network, and we can go to, we can expand the this data source. And if we check the road net line, we are going to make a network from this road net line. You can go to traffic analysis and click on network by topology. Click on structure to the network. Our data that we are going to build the network dataset is the road net line. We can set the name result as junction network. So we need to make it different from others. And click split line by points. Actually, this is optional, but you can just let it default and click OK. And wait for a while until the result is appear here. If you drag it to this map window, it will give you a similar but actually difference because our network result is contained of two layers, as node and as line. If you turn off, this is the node and this is the line. And node information is let us know about the direction of the line. It should be from this one to this one or vice versa. And the information is archived on each node. Okay, the next part is you can go to traffic analysis. We have some option here of traffic analysis. I think since we don't have, since the time is limited, so I will just show you some of the path analysis. First one is optimal path analysis, used to find the ordered paths of the least resistance between 2 points or more in the network. The least resistance has different meanings, such as those based on a single factor, like the shortest time, the lowest cost, the best traffic condition, the minimum toll stations, and others. Okay, I will go back to SuperMap iDesktop. Then you can go to traffic analysis. Click on optimal path. This one, an instance management window will appear on the right side. We can click some stations, for example, this one to this one, and click run. Let's wait moments because it still need to check data. While waiting this step, I will let you know others. Network analysis in SuperMap. We have also traveling salesman problem or TSP analysis. It's an order path. The TSP analysis can decide the order to visit the nodes, and its target is to get the minimum or close to the minimum summary of the travel route impedances. So the difference is that in the optimal path analysis, we define the order from the stations 1 to the stations 2 to the stations 3 and so on. While in the traveling salesman problem, it's unordered. So if you define 3 or 4 or more stations, for example, station 1, 2, 3, and 4, the software will give you the order that calculated by the software. So it will not from the first one to the second one and until the last one, but software will calculate which station is the best one to go at first, and then which one is the best one to go as the second station, and so on, so that if we summary them all, we can have the one that have the minimum road impedances. It can be the minimum time, the minimum distance, or other based on your requirements. Let me cancel this tab. And okay, we can click yes on this. All right. This is the result from the stations 1 to the stations 2. This is the best route. If you want to change the information, the weight or others, you can change here. Here I choose the weight is length. That means that the best route is the one that have the minimum length in total. If I add other stations, it will be like this. Okay. Okay, now we go to the next part. For example, the TSP part. So if we click some stations and click run, it will let you know which one is the best one to go, which is from the stations 1 to stations 4 to stations 3 to station 3 to station 2 and then to station 3. So it's not give you the sequence result, but give you the optimal result to go to all of the stations and also the best sequence to go to the all stations. Okay, so I think this is for the network analysis. And then we go to the raster analysis. You can save or not, but this time I will not save it. you can open the data source. Okay, I need to unzip this. Sorry. And right click and select the analysis raster here. Contains points that have information about temperature and others. You can right click and take a look here, and it's stored about temperature here. And we are going to do interpolation and clip for raster. And to do so, you can go to spatial analysis, and we have here raster analysis. Click on interpolation. We will be using inverse distance weighted here for the method. The data set we are going to interpolate is AWS, and the field is temperature. For the rest parameter, I will just let it default. Finished. And this is the result. Okay, it's, as you can see here, it predicts the value for area that have no data, but we are going to clip the result because what our requirement is just to get interpolation result from for the China boundary. And to do so, you can go to data, and then we have here raster clip. The source data is the interpolation result, and the boundary is China. Click, for example, this one is temperature for China. Click OK. Okay, this is the result. Now our result is only specific for the China boundary. Oh, sorry, I think I select the wrong parameters. Let's do it again. Interpolation. This one is China. Interpolation. Oh, it should be this one. Use specified region dataset and use China. Okay, now it's specific for the China boundary. All right. For example, you want going to create an ISO line for the temperature for ISO region. You can go to spatial analysis, surface analysis. We have extract ISO lines here. And choose the clip result one, this one. And click the ISO line dataset. You can change the interval, for example, 20, 10. Okay. And this is the result. And if you want to create an ISO region, this one, data, clip result one, interval is 10. Okay, and display the result as follows. This result means that the area that have same line would have same temperature, and also area that have the same boundary region have the same temperature. So more details about our raster analysis, you can take a look in my PPT. So I think that's all for today session. After this session, I will send the homework so you can try by your own by using our data. and give us the results so we can review your results. I think that's all for today.